Short lesson, easy lesson. Okay, this is a pretty easy chapter, pretty friendly chapter. You know, or maybe not. I don't remember. I think maybe we hit proofs again tomorrow, but we'll see. We'll see. By the way, my cousin Goth Perich is going to be teaching you tomorrow. Just some fun facts about him. He hates everything. He is miserable all the time. He loves death metal and emo music. He, well, I mean, nowadays emo kids like put hearts under their eyes, and that's ridiculous. He's not emo. He's more goth. He loves eyeliner. He loves painting his nails black with Sharpie. So he's going to teach you guys tomorrow afternoon. Please be really nice to him. He's very sensitive, and he doesn't understand human interaction very well. So tomorrow is the day. Are they your alter egos? Lol. No, they're my cousins. Why would you ask that? All right. Two angles A and B, are vertical. The measure of angle A is that. The measure of angle B is that. Vertical means that they're angles that are across from each other, which means they're equal. So get some scrap paper or your notes or whatever it is that you draw stuff on, and in about 30 seconds or a minute, if they're equal, then you know what to do. I want you to find X. It says find each angle, but let's find X first. Set a timer for a minute. And once you have what X is, please paste it in the chat. Whoever gets it first wins. I already said they're equal to each other, so while you guys are doing that, I'll write out the equation. Santiago, the question was asked, what do you win for writing the answer out first? My admiration and respect and love and friendship and kindness. All right. Still, if you beat me, then you beat me. I can't really answer this question, find my angle, because I foolishly picked an answer that won't make sense, and we'll see if one of you can understand why my answer can't possibly work. All right, so let's subtract 8x from both sides. I always like getting rid of the smaller variable first when you have variables on both sides. That gives me negative 20 equals 2x plus 20. It's not worth it. That's hurtful. Let's subtract 20 again. Camilla's saying negative 20, and that looks right to me. Now, in a second, I'll ask her, or anybody for that matter, why that answer can't possibly make sense. But we're not there quite yet. Cross you out. Let's move this over here. Negative 40 equals 2x, regular 2x. Divide by 2, and x does equal negative 20. What would happen if I was asked to find out the measure of each angle and I plugged in negative 20? What type of answer would I get for both answers? I'm not looking for a number. I'm looking for a type of answer. What type of answer would I get if I were to plug in negative 20 into either of these angles? Yeah, like Camilla, which one? Good. Yeah, a negative number. And you can have negative angles. Negative angles don't exist. So thank you, girls, for taking the lead on that one. When I originally made this problem, I think this was the exact same problem that I gave you last time we had class. And I'm not sure why I repeated these problems. It was a total accident. So I scratched it out and said, let's just make them equal to each other without even thinking that. It's literally impossible. So the math is what matters here, not the fact that I screwed up. Let's remember that. The fact that I screwed up doesn't matter ever. It's just the fact that the math worked out nicely, and you leave me alone and stop harassing me. What are we doing today? Brace yourself. Triangle congruence problems are coming. Oh, ha, ha, ha. We all love a good Game of Thrones reference. Game of Thrones, of course, a TV show that none of you should watch because it's far too mature. It even makes me blush. And the things that I've heard and seen. I will be able to use congruence to find missing sides and make proofs. Congruence means equals, simply put. So the majority of the problems that we will deal with today are going to be like, look, these two triangles are congruent, which means, okay, well, we'll probably then have to set things equal to each other. That's the majority of our problems are going to look like. So we're at 4-2 congruent triangles. Now, lots of vocabulary there. And of course, if you have the notes, which I send you, and if you were to print them out in the perfect world, you would have these printed out. But the only person that's perfect is God. Yes, thank you, Camilla. You're allowed to say it. I'm not allowed to say that God is perfect or Jesus because of separation of church and state. Recall that if a geometric figure can be mapped exactly to another geometric figure, they are congruent. All this stuff is just saying, look, we're never going to use. I'm never in a million years going to use the phrase the principle of supposition, or I'm sorry, superposition. See, I can't even say the word. I'll never use that phrase ever again. What we have to know is congruent means the shapes are exactly equal in every way. The same exact shape, the same exact size, the same exact length. So if I were to cut two congruent shapes out and place one on top of the other, the one would fit perfectly on top of the other one. They might be rotated, but after I cut everything out, if I rotate it, I should be able to put one on top of the other. When I say corresponding, what I mean is which angles are the same exact angles. So when I look at this picture, and let me blow it up a little bit. No, wrong button. When I look at this picture, right, you can see some of these angles where that C there has a triple line. That K there has a triple line. And the triple line angles means that they're the same exact angle. So I could say that angle C and angle K are corresponding angles. JK, just kidding, has a double line on its line, which means JK is corresponding and congruent to which angle up there. I'm sorry, which line up there. Line JK down here is congruent to which line up there. Please type out the two letters that it corresponds to. Hey, not everybody all at once. Hey, slow down, you guys. Hey, guys, come on, slow down. It's really easy. Can they hear me? Can you hear me, Miss Harris? Because, yeah, okay, I thought so. See how JK has a double line here? See how BC has a double line there? That means they're congruent. That means they correspond, okay? I'm not sure I have everybody's attention. So what I want you to do is I want you to right now put your, if you could change your name to any name you want, I want you to type it in the chat. Don't hit enter yet. I want you to type it in the chat because I need to make sure I have all 12 of you paying attention because I'm not convinced I do. Camilla, I know, pays attention. I know the majority of the girls pay attention, but I'm not so sure about my bros here. If you could, well, I'm sorry, Russ, maybe you. All right, so I want, if you could change your name, your first name to any name, I want you to type it out. Like I just did. And on the count of 3, hit enter. If you could change your first name to anything, what would it be? 1, 2, 3. You guys are awful. Oh, I'll take it. So we're all very happy with who we are, or we all just want to insult me. Either way, again, Miss Harris, another lesson learned is you can't be kind to children, otherwise they're just going to be extremely rude and hateful to you. So Megan's not paying attention. It seems like. Where's Elena? Oh, I'm sorry, Elena, you're P. Jill, you're paying attention. Where's Chris? Chris probably Harless Fern. Thank you, Megan. So we're good now. Everybody is happy. All is well. Corresponding means that the angles A corresponds to H because of the two double curved lines. B corresponds to the J. C corresponds to the K. Line AC corresponds to the line HK. Line BC to JK. Line JH corresponds to BA. And we could say the phrase that triangle ABC is congruent to triangle HJK. And we use the fact that since A matches up with H and B matches up with J and C matches up with K, we use that exact order. I'm not going to say ABC is congruent to KJH because you're now implying that A corresponds to K, which it doesn't. Okay, so there. Now let's apply this stuff to examples. I'm assuming that X here is the 4X and N I don't know. What can I do? You can either unmute yourselves or put it in the chat. I mean, I mean, 4N or 4X, if these guys are exactly the same, 4X is equal to N, but I don't see anything for N. So any ideas? What 51? Are you saying that X is the same as 51? No, I don't. No, I don't think that's going to work. Oh, you're saying this X is 51. Why would you say 51? Because of this guy? Okay. The question that I'm asking is X is the same as N. Okay. I don't see N, though. Could I find N? And how could I find N? I'll give you a hint. This is what we did on Monday. Good. That's half of it. So Santiago is saying we could subtract N by doing, or we could find N by saying 180 minus 65. Will that give me all of N, or do I need to continue that statement? Because 180 minus 65 is going to give me like 100 something and 51. Good. So what I could do is I know that the three angles in a triangle add up to 180. So this already has 65 and that already has 51. So N is going to be what I get after I subtract 180 minus 65 minus 51, which I believe is 64. Okay, thank you, Lily. Yep, Lily beat me to it. Good job. 64. Nintendo 64, right, gang? You don't know what I'm talking about. All right, so N is 64. Somebody type out in the chat what equation I'm going to set up to find my value of little x. Not big X, little x. Good. So I'm going to do 64 equals 4x. I'll give you a 30-second head start for you to type out what x is in the chat. Okay, 30 seconds wasn't needed. 30 seconds, 3 seconds. My little overachievers. My little overachievers. So I have 3 16s. Ooh, 316. Got a smirk from Carrie. She gets it. John 3:16. Only the most important verse in the Bible. Let's divide by 4. Let's divide by 4. And x does equal 16. Yes, Athena, 61 backwards was thank you. I'm not sure why that had anything to do with anything, but yes, good. 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 All right, so again, with many of these problems, it's all a matter of trying to figure out, well, It's giving me two shapes. Something's got to equal something else. Do I have enough information to create an equation to solve what I need to solve for? And in this case, it took me kind of doing what I did the other day and then combining it with what we're doing now to come up with an answer, and that answer is 16. Dope job, gang. In the diagram, ABC is congruent to angle, triangle ABC is congruent to triangle DFE, not DEF, DFE, which means the way that they have the shapes drawn out is exactly the way it's supposed to be. So I'm looking at my two shapes, right? I have to find an X and a Y. Which one must I find first? Good, Camilla. Now, why can't I find X? Well, this equation has 2y plus x equals that, which means I can't find a specific variable yet. However, if I set these two equal to each other, I can find y. And once I find y, I can plug it in there, then find x. So that's what I want you to do. I want you to take about a minute and a half and find out why. It looks like I have decimals here, so my answer might be a decimal. I honestly don't know. We shall see. Set a timer for 90 seconds. And I want you to...
Okay, your timer is set for 1 minute and 30 seconds.
I want you guys to do y first on your own. Since these two triangles are congruent, then these two guys are equal. Go. Okay, so Lily has an answer. I'm going to at least write out the equation for those of you who need that first step. Lily, is that 1.3 or 13.5? Or that's 13? That might be a bit too big. Oh, heavens me. I'm such a dunderhead. What did I do wrong? You see what I did? I'm going to show you what I did. I did something stupid. I did something dumb. Look at what I did. I solved this 8y minus 5 and thought df was 8y minus 5. And my terrible, terrible eyes didn't notice that it's an actual angle pointing to f. So Camilla's right. And Lily, you're probably right. So 13 might be it. So I made the mistake. 8y minus 5 isn't equal to 32.1. It's equal to 99. My eyes are deceiving me. Okay, so sorry, Athena. Sorry, Camilla, and anybody else if I confused you. Camilla is now confirming Lily. Again, if I had better, I blame this on my terrible eyesight, which is not my fault. It's my dad's fault. And my mom. But mostly my dad. 8y equals 104. Is y all by itself? No. What's in the way? 8. 8. So I think we can all agree with Lily that y is 13. Now that I have y is 13, I can replace the y in the other guy by 13. So I could say 38.4 equals 2 times y, which is 13 plus x. So Lily has a decimal for an answer. It's probably right. She knows more than I do. Santi is confirming it. Athena is confirming it. So if I multiply those guys, I get 26. Subtract 26, subtract 26. And what is that? 12.4? Oh, how about that? It just shows up as 12.4. So, yeah, you guys are good. It's Camilla confirmed. Okay, I like it. I like it. That's pretty dope, guys. Guys, a pretty dope job by you. Pretty lit and dope. Which reminds me, make sure that after we watch the video, you join my Gen Z Kahoot tomorrow. So it's going to be thirsty. No. I said something wrong there. Lily's encouraging me. Yay! Just like you guys encouraged me when you found out I had a TikTok. When they found out I had a TikTok, Miss Harris, they were mortified. So all I know is I can't wait to start videotaping myself going like this and then putting some sassy phrases up there. And then probably listening to some random rap song I've never heard of before at the same time, because that's what TikTok is. CPCTC is an acronym. And it's an acronym that we're going to use every now and then. It means that once two triangles are proven to be congruent, then three pairs of sides that correspond must be congruent to the three pairs of angles. So if I can prove that these three sides are the same, then I can prove that three's angles are the same. And you did do it wrong, Camilla. Very good. If I can prove that three sides are the same, then I can prove that three angles are the same. CPCTC. It's something that we will come back to and remind ourselves of a lot. And it'll show up in proofs a lot. Speaking of proofs, if I want to prove triangles are congruent, the triangle angle sum theorem says that if I have two triangles on one, or if I have two angles on one triangle and two angles on the other triangle, then it must be the case that this angle and that angle are going to be equal to each other too. So let me reword that. I worded that terribly. If I have two angles over here on this triangle and two angles over here on that triangle, and this angle is the same as that angle, and this angle is the same as that angle, then it must be the case where the third angle in each triangle are equal to each other. That's called the third angles theorem, the TAT, if you will. TAT talk. Speaking of TAT, so third angle theorem, Let's take a look at some other stuff that we already know. Reflexive property means an angle or a triangle equals itself. Symmetric means if I were to say this triangle equals that triangle, then that triangle equals this triangle. And the transitive property is basically saying if red equals blue and blue equals green, then red equals green. I know that's hard to understand because I use colors that aren't equal to each other. But if never mind. So here we go. Is this the only thing that we're going to do? Yep. So we have time. So we're going to take that picture there and we're going to make a proof based off of that picture right there. Okay. Now, what I probably need to do for this chapter is start making more everyone proofs videos and post that. I might have, instead of teaching you guys a brand new proof lesson tomorrow for my cousin, I might have him do something completely different. But we'll see. We'll see. I don't know. He might be too depressed to teach that stuff. Given angle. So let's take this picture here and let's draw out information that we know. Given WXZ, that angle is congruent to YXZ. So WXZ is congruent to YXZ. So I'm going to put one little loop on each. That's supposed to be a loop. It looks terrible. Better. XZY. 8 minutes left in class. XZY is congruent to XZ. I'm sorry. XZW is congruent to XZY. XZW is congruent to XZY. WX is congruent to YX. WX is congruent to YX. What color didn't I use? Purple. And WZ is congruent to YZ. I need to prove that the two triangles there are congruent. So I have my statements. And my reasons. So just to save some time, because we don't have all the time in the world, and knowing how my touch screen works, I think you guys can forgive me if I just do this. Blah, 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 blah. Given. Okay. Are you guys okay with that? And if in the future, one time you decide to go blah, 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 given, I'll forgive you once. Once. Here's what we can do. If angle X, see how that, okay, so these are the two triangles that we need to prove are congruent. These two triangles need to be, I need to prove that this triangle on the left is congruent to that triangle on the right. Since that angle is equal to that angle, and that angle is equal to that angle, then what two angles are also equal to each other? What two angles are also congruent to each other based off of the fact that red and green are congruent to each other? Just type out the two letters. I have a cat scratching at my window and it's driving me bananas. All right, so since no one's going to say it, if X and Y, or these two guys are equal, and these two guys are equal, then the third angle theorem says that W and Y are also congruent. So I could say XWZ is congruent to angle XYZ, and that's the third angle theorem. So what I have now is I have all three angles equal to each other. I have two sides equal to each other. And this is going to be weird. Okay. I know that the blue dashes are equal to each other and the purple dashes are equal to each other. There's got to be a third line that's equal to each other. Well, this is the case. These guys share a side, which means XZ is congruent to XZ. So my third thing is line XZ is congruent. That's supposed to say is congruent, but the lag, oh, for goodness sakes, if I were to ever accidentally reset an entire proof, I'm going to lose my mind. Line XZ is congruent to line XZ. So line XZ is congruent to line XZ. And we haven't used this property in a while, but we're going to use this property a whole lot with triangles. That's the reflexive property. When you say something equals itself, that's the reflexive property. Now, see these three sides? We have two shapes. All the angles are congruent. All of the sides are congruent. Now I can finally say in my last step of this proof that the two triangles are congruent. So I could say triangle WXZ is congruent to triangle YXZ. And my reason is the definition of congruent triangles. Or I could say the definition of congruence. Congruence or congruent triangles. The only way they're congruent is if all three sides and all three angles are equal to each other. And in this case, they are.